This is section 4.3, finding trigonometric ratios. I'm calling this part 1 because there's more to section 4.3 than just finding trigonometric ratios. This is on page 10 of your unit handout. So what we're going to be doing today is writing 6 trigonometric ratios given a point that's on the unit circle. There's 6, right? Not 3, there's 6. There's sine of theta, cosine of theta, tangent of theta, and there's 3 more that you haven't been taught yet, but we will learn them today. We are also going to be using a calculator to determine values of trigonometric ratios, whether it's in degrees or radians. And you might go, well, geez, we're going to actually learn how to use a calculator to find trig ratios in Math 30, and the answer is yes, because those other 3 trig ratios don't have trig buttons on your calculator. You have a sine button, a cosine button, and a tangent button, but you don't have those other 3. And then we're going to be going back to the unit circle and determining exact values of trigonometric ratios for any rotation angle. For example, you should be able to figure out that the sine of 315 degrees is negative root 2 over 2. Or that the cosine of, no, we'll go 5 pi over 6, that the cosine of 5 pi over 6 is negative root 3 over 2. That's going to be not only just useful, but mandatory to know those things. And then we're going to repeat what we learned about finding 6 trigonometric ratios for a point on the unit circle with a point that's not on the unit circle. Because terminal arms can be extended indefinitely. They intersect the unit circle, but they also intersect other circles. And if I give you one of the 6 trigonometric ratios and enough supporting information, what are the other 5 trigonometric ratios? This is a pretty packed lesson in terms of types of questions. Let's start by going back to Math 20-1. At some point in Math 20-1, you walked away from cos of theta is adjacent over hypotenuse, and sine of theta is opposite over hypotenuse, and tan of theta is opposite over adjacent. And you know those 3 formulas I just said, the SOHCAHTOA? That was on your Math 10 formula sheet. I don't know if you remember that, but it was. And then all of a sudden in Math 20, we said, no, we want to talk about rotation angles. Let's take adjacent and replace it with x. Let's take opposite and replace it with y. And let's not call it the hypotenuse, we're going to call it r. And those 3 formulas disappeared from your formula sheet, and these appeared in Math 20. Okay, well, I'm going to tell you right now, these are not on your formula sheet anymore in Math 30. You need to know those definitions. And of course, the relationship between x, y, and r is that x squared plus y squared equals r squared. And this is not necessarily the unit circle. This r could be 8, right? It doesn't have to be 1. So r can be any number at all. It can be 1, but it doesn't have to be. So now what's new? We have what are called reciprocal trig ratios. And each of the 3 primary trig ratios, these 3 things are called primary trig ratios. Cosine of theta, sine of theta, and tangent of theta are primary trigonometric ratios. The secondary trigonometric ratios are paired up with the primary ones. So each of the primary has a secondary or reciprocal trig ratio. And let me show you what this is called. This is called secant of theta. And we don't abbreviate it. I mean, cosine of theta can be abbreviated verbally by saying cos theta. Secant of theta is never pronounced sec theta. It's pronounced secant of theta. There's no verbal abbreviation. And what secant of theta is the reciprocal of cosine of theta. But I want to draw your attention to something right out of the gate. This is the only mathematical operation in the world that is the same in both directions. If secant of theta is the reciprocal of cosine of theta is the reciprocal of secant of theta. Let me demonstrate that to you. if I take secant of theta, which is equal to 1 over cos of theta, and I cross multiply, I get secant of theta times cosine of theta equals 1. And if I divide both sides by secant of theta, I get cos of theta equals 1 over secant of theta. But we started off with secant of theta equals 1 over cosine of theta. I'm telling you, yes, on your formula sheet it says secant of theta is 1 over cos of theta. Secant of theta is the reciprocal of cosine. But what it really is they're reciprocals of each other. Okay? And as I said, a reciprocal is the only mathematical operation in the universe that doesn't matter which way you go, it's the same thing. It's the same meaning. This is called cosecant of theta. And again, it just turns out that there's no verbal way to abbreviate that. And this is called cotangent of theta, but we do abbreviate it verbally by saying cotan theta. Although these are on your formula sheet, having to go to your formula sheet each time to find out which one we're interested in can be a bit of a chore and slow you down a little bit. I was always taught, and this was back before we had a formula sheet. I mean, they existed, but it just wasn't on the formula sheet when I went to high school. I was taught that each of these pairs has a co in it. There's secant and cosine. There's cosecant and sine. There's tangent and cotangent. And obviously, tangent and cotangent go together. So as a high school student, if I said, well, which one goes with cosine, I would go, well, maybe it's cosecant, and then I would say, no, it can't be cosecant, because then I would have two cos, cosine and cosecant. Cosine already has that co in it. It must be secant that is the reciprocal of cosine. Just food for thought. So on your formula sheet, and there's some stuff here that you don't know yet, but on your formula sheet, this is where they're located if you're looking at a formula sheet. And what does this mean? It means that if cosine is x over r, which you knew in Math 20 and you're expected to know, like immediately, if cosine of a rotation angle is x over r, then secant, which is the reciprocal of cosine, is r over x. If sine is y over r, then cosecant, which is the reciprocal of sine, would be the reciprocal of y over r, because it's the reciprocal of sine, which would be r over y. And cotangent is the reciprocal of tangent. Tangent is y over x. Cotangent is x over y. So these are the 6 trigonometric ratios for any rotation angle, whether the terminal arm is intersecting the unit circle, producing a value of r of 1, or not intersecting the unit circle, producing an r of some other number. And you need to know them. None of this is on your formula sheet. The only thing that's on your formula sheet is what I've highlighted, among other stuff that's trig related but not related to this. So these are the 6 trigonometric ratios. I want you to notice something, and I would ask you to know these trig ratios. But if the point is on the unit circle, then r is 1. And if I put 1 in for r, every place there's an r, cosine just becomes x. Sine just becomes y. Secant becomes 1 over x. And cosecant becomes 1 over y. I just want to make it clear because I think... Good. Can you turn the page, please? Yeah, I think at the top of the next page I put this, and part of me regrets putting this. I don't want you to memorize this. I don't want you to think, oh, I got to memorize these 6, and then memorize what if it's on the unit circle. This that you're looking at on the screen is included in here. You need to know these 6, and if r is 1, then use r equals 1. All right, let's take a look at some examples now. Use our knowledge of the unit circle to determine the exact value of sine pi over 3. Again, I don't want you to look at the unit circle immediately upon seeing a question like this. What I want you to do is the following. and I'll go freehand because that's what you're doing. I want you to recognize that pi over 3 is in quadrant 1. And if I were to draw a quarter circular arc here, pi over 3 is this angle up here, or this position up here. Pi over 3 is actually this rotation angle. And the key to answering this question and any of the ones in question 1 is knowing the coordinates of the point and knowing, in this case, that sine of theta is y over r, right? So what are the coordinates here? Is this one of these ones, without looking at your unit circle, that x and y are the same number? No. That means one of these numbers is a half, one is root 3 over 2. I think you can see quite easily that x is a half, because if I were to extend this down, and, it's not going to be exactly half because I've kind of drawn it freehand, but it's pretty close to a half. Your circle has to be really, really non-circular for you to look at it and go, I don't know, is that a half? Or is it root 3 over 2? Which means that y is root 3 over 2. But we're using the unit circle here. And r is 1. So this sine of theta equals y over r turns into sine of theta equals y. Because r is 1. So this is equal to root 3 over 2. And what that means is the sine ratio of an angle of pi over 3 is root 3 over 2. If you had your calculator in radian mode and you took the sine of pi over 3, you would get a number, a decimal approximation to root 3 over 2. Does anybody remember what that number is about? .866. See, and that might be helpful later because if you see that number, you might go, oh, right, it's root 3 over 2. All right, cosec. Okay, so now all of a sudden it's different. It's got a negative angle, which you wouldn't really be expected to work with for a trig ratio last year, and it's cosecant. The first thing we have to do is say to ourselves, what is cosecant of theta in terms of x, y, and r? So this is the thought process that happens. Or you can go to your formula sheet. You say to yourself that cosecant of theta is the reciprocal of sine of theta. And then you say, since sine of theta is y over r, cosecant of theta is r over y. But we're going to use the unit circle. And that means r is 1. You might say to yourself, why are we allowed to use the unit circle? May I borrow this again? You're allowed to use this if you have a radius of 1. Well, we can use a radius of 1 because we have intimate knowledge of these coordinates. We could use a radius of 5 if we had intimate knowledge of the coordinates if r was 5, but we don't. We have knowledge of the information when r is 1, so we make use of it. So what we are looking at here then is that this will be equal to 1 over y. It will be equal to the reciprocal of y at negative 5 pi over 4. So where is negative 5 pi over 4? Well, pi over 4 rather is a 45-degree chunk starting at 0. Here's negative 1, negative 2, negative 3, negative 4. Negative 5 pi over 4 is there. Ish. And we should know that the coordinates at that point are the 1 over root 2, 1 over root 2's. In this case, x is negative and y is positive. So y is 1 over root 2. That means the reciprocal is root 2. The cosecant of negative 5 pi over 4 is root 2. The reciprocal of y. I hope that you understand I did not have to do that. I could have said negative root 2 over 2 and root 2 over 2, and then said the reciprocal of y is 2 over root 2. Okay, but if you look at what we did, this is cleaner. I anticipated that I'm going to take the reciprocal of y, so if I take the reciprocal of 1 over root 2, I get a nicer looking number than taking the reciprocal of root 2 over 2. The results are the same. Root 2 that we got for an answer and 2 over root 2 are the same. Let's try another one. Tan of negative 11 pi over 6. So tangent of negative 11 pi over 6 will be equal to y over x. This is something that needs to be known. Tangent is y over x. So we need to know the y and x coordinates at negative 11 pi over 6. Pi over 6 is a 30-degree chunk. So negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8, negative 9, negative 10, negative 11. Right here. That is theta. So what are the coordinates at that point? Well, that's one of those, I call it the oddball position, where x and y are different. One of these numbers is a half. I mean, I can see quite easily, I hope you can as well, that is the y coordinate that's going to be a half. If I just look this way at y and this way at x, I can see which one is a half, which means this is root 3 over 2. I need to take y over x now. I need to take a half divided by root 3 over 2. Now, in the next unit, there's going to be a lot of algebra, a lot of work with rational expressions and fractions. And I know that in earlier grades, particularly junior high, but also probably in grade 10 and maybe in 11, depending on who taught you, your teacher would have said the simplest way to approach this is when you divide by a fraction, you multiply by the reciprocal. Remember that rule? I don't want us to lean on that rule because there's a better rule that always works, and multiplying by the reciprocal does not always work. The better rule is to recognize that this is a complex fraction which has many denominators that I want to kill. I want to get rid of those denominators. And I can do that by multiplying the top and the bottom of this by 2. The result is going to be the same as multiplying by the reciprocal, but doing this is useful for other things rather than just this situation. So you need to get used to it. Which means the tangent of negative 11 pi over 6 is equal to, we're left with 1 on the top, root 3 on the bottom, and you should recognize that this is root 3. Just like, well, not just like. The reason it's root 3 is if we rationalize the denominator, this is from Math 20. Pardon me, it's root 3 over 3. It's root 3 over 3, not root 3. The reason is if you rationalize the denominator by multiplying the top and the bottom by root 3, you're left with root 3 on the top and 3 on the bottom. It's just like, everybody, this. It's just like recognizing that these two things are equal. And there's no, I wish I could tell you that everybody's always consistent, but I can't. You might write a diploma exam, and someplace on the diploma exam they will have this for an answer, and on the very next diploma exam, they choose to put the other one as an answer. You have to be adaptable. Let's try one more. Cosecant of 3 pi over 2. Cosecant, well, I'm not going to write this down, I'm just going to talk it out. Cosecant is the reciprocal of sine. On the unit circle, sine is y. That means cosecant is the reciprocal of y. We need to look on the unit circle at 3 pi over 2, look at the y coordinate and take the reciprocal of it. And at 3 pi over 2, that's here. You shouldn't need to think very long about that to know that the y coordinate is -1 on the unit circle, which means this will be the reciprocal of -1, which is -1. Cosecant of 3 pi over 2 is -1. Cos of 240. Well, that's the x coordinate on the unit circle at 240 degrees. So I would challenge you to try to visualize where 240 degrees is on the unit circle and recognize that it has an x coordinate of -1/2. How many of you see that it has an x coordinate of -1/2? If you don't, the next step would be to say, do you see that 240 degrees is there? And you should. Do you see now that the x coordinate is -1/2? If I extend this up, that looks like -1/2, and it is. So this is where we're kind of going, that you're just getting better and better at this. You're just looking at this either on paper. I mean, again, and I'm going to borrow this again. You have this to look at, but don't immediately go to it every time, because you can't do that on an exam. Unless you have, a photographic memory, in which case you don't need the sheet of paper anyway. But I would rather you understand it. So for example, secant of -45 degrees. Okay, secant is the reciprocal of cos. On the unit circle, cosine is x. Oh, okay. So on the unit circle, this will be the reciprocal of x. Well, I know x at -45 degrees, and I'm going to draw it in a second. I know x at 45 degrees is positive root 2 over 2, or positive 1 over root 2. So I just reciprocate that. -45 degrees, though, is here. This is the point where I didn't draw this perfect, but this is 45. This is where these are both 1 over root 2's, except I guess y would be negative because it's in quadrant 4. This is x right here. Oh, reciprocal of that is root 2. Secant of -45 is root 2. And again, I chose to go with the 1 over root 2 because I anticipated the fact that I'm going to reciprocate it, so it becomes a little bit cleaner. Tan of 510. We got a bit of work here. 510 is past 360. So the first thing that you need to do is ask yourself where 510 degrees is on the unit circle. I'm thinking it's here. I'm taking 510 degrees and subtracting 360. I think I get 150. Oh, okay, so that I can go a further 150 degrees. Watch very carefully and listen to what I'm saying. This angle is 150. This angle is 510. It's the same location, different rotation. I really hope that you are getting really good at this, at picking out those coordinates. This is an oddball position on the unit circle. We're dealing with root 3 over 2's and 1/2. Looking at it, I can see that y is 1/2, x is the root 3 over 2, and of course x is negative. Tangent is y over x. So tangent of 510 is 1/2 over negative root 3 over 2. Multiply top and bottom by 2. And we get for an answer negative 1 over root 3, or that. I really think you're getting the idea here. Let's just do cotan 540 quickly. Where's 540 degrees? I want you to figure it out. Oh, I think that's over here, isn't it? Because you go 360, I think you need another 180. Oh, wow. That's like taking candy from a baby, because this is a pretty easy ordered pair to figure out on the unit circle. Cotangent is x over y, because tangent is y over x. So this is negative 1 over 0, which is what? It's negative 1 divided by 0. Can't divide by 0. It's not defined, undefined. So if you had, and you don't, if you had a cotangent button on your calculator and you tried to take the cotangent of that, you would get undefined.
Can you go back? Because I think you did the other way around. I think you did the cotangent.
We're talking about this one?
Yeah. Isn't that the cotangent?
But this is tangent, which is y over x.
Yep.
So I took the y coordinate here, which is 1/2, and divided by the x coordinate, which is negative root 3 over 2. This one is cotangent, so I don't go y over x, I go x over y. Are you okay with that?
Yeah.
Okay. Sorry. All right, now this is next little bit of business is just to learn how to use our calculator. How would you find on your calculator a decimal value for the cotangent of 7 pi over 8? Well, you need to be in radians, first of all, because we're going to use 7 pi over 8, which is a radian measure. But you don't have a cotangent key, do you? And I want to really avoid here a mistake that students make. And it's a horrible mistake. It shows a real lack of understanding of something. And we don't want to get sucked into this pit. Forget about this angle for a second. Cotangent of theta is equal to 1 over tangent of theta, right? So cotangent of r is equal to 1 over tangent of r. Cotangent of 3 is equal to 1 over tangent of 3. So cotangent of 7 pi over 8 will be equal to 1 divided by tangent of 7 pi over 8. Just going to clean that up a little bit. That's what we have to enter into our calculator. What some people do, and I kind of get why you might be tempted in this direction, is some people think you have to take the 7 pi over 8 and flip it over. You don't. That's the angle. You flip over the tangent. You don't flip over the angle. So when we do this, all we do for this question is we put in our calculator 1 divided by tangent of 7 pi over 8. I suppose you could go tangent of 7 pi over 8, hit equals, and then go 1 divided by the answer. So just make sure that you are able to get negative 2.414. This is a decimal approximation. Well then, how would we find secant of negative 5 pi over 11? It would be 1 over cosine of negative 5 pi over 11. The angle is still the angle. We're reciprocating cosine because cosine is the reciprocal of secant. And again, make sure you can put that into your calculator and get 7.0266. Are you with me? Okay, good. Well, sine of 35, it's a grade 10 question. Just put your calculator into degree mode. There's a reason why I'm asking a grade 10 question here, and it might become apparent in a minute. Put your calculator into degree mode. Calculate sine of 35. And I'm not sure why I have that there. I don't want that there. Sine of 35, you should get 0.573576, yes? Now I want you to calculate cos of 20. And cos of 20, of course, is equal to 0.408. There's no degree symbol there. I put the sine of 35 to suck you into putting your calculator into degree mode. But then when we look at cos of 20, there's no degree symbol. That's cosine of 20 radians because there's no degree symbol. So you need to be on your toes for that kind of thing. We have to be back in radians here. Radian mode. Okay. I've kind of laid the groundwork now for the rest of the lesson, which is quite a few examples, but it's really simple math. We need to know sine of theta is y over r, cosine of theta is x over r, tan of theta is y over x, cosecant of theta is the reciprocal of sine, secant of theta is the reciprocal of cosine, cotangent of theta is the reciprocal of tangent. We have that in our head, and we know that x squared plus y squared equals r squared. We're golden here. This is easy. It really is. First of all, number 3, the point negative 5 over 13, comma, 12 over 13 is on the terminal arm of an angle. How do we know if that's on the unit circle or not? We're told it is, but how can you prove that it's on the unit circle?
X squared plus y squared equals 1.
Right, we go use x squared plus y squared, and if we get 1, it's on the unit circle. So we could do this with exact values. You could do it just on your calculator. I'm going to do it with exact values. When I square 5 over 13, I get 25 over 169. When I square 12 over 13, I get 144 over 169. I'm sure it isn't lost on you that I said when I square 5 over 13, and I didn't say when I square negative 5 over 13, because when I square a negative, who cares? It becomes positive. 25 plus 144 is 169. This is 169, 169s. This equals 1. What does that mean? It means that to find the trigonometric ratios, we can use r equals 1. What are the values of the 6 trig ratios? Well, it's on the unit circle. So cosine is the x-coordinate, negative 5/13. I don't think you even need to say divided by r, which is 1. On the unit circle, cosine is the x-coordinate. What is the sine of the rotation angle? Well, it's 12/13 because it's on the unit circle. And yesterday we learned the y-coordinate is the sine of the rotation angle on the unit circle. What is secant? Secant is the reciprocal of cosine. Now, be careful here. If I take the reciprocal of negative 5 over 13, I get 13 divided by negative 5. Yes? But if you've had me as a teacher before, you will know that this makes me ill seeing negative on the bottom. I like it on the top. You could put it here, but I don't like that as well because sometimes you don't notice it. The negative is so close to that fractional symbol that it blends in. I prefer it here. Cosecant is the reciprocal of sine. As I said, this is easy. Tangent, a little bit more work. Tangent is y over x. Y is 12 over 13 over x is negative 5 over 13. I think you should be able to see that if I multiply the top and the bottom of that by 13, you're left with 12 over negative 5. Yeah.
Is there ever going to be a time when the many denominators are not the same number?
I'm going to answer that in a second. So we get negative 12 fifths, and I just put the negative on the top, and we get negative 5 twelfths here. What Ariana is asking is, will it ever be the case where the two denominators are different? And I can conceive of it being yes. But if the two denominators were different, like a 3 and a 2, you'd multiply the top and the bottom by 6. You're multiplying the top and the bottom by the common denominator of all of the little mini denominators. Certainly when we get into the next unit with the algebra and the trigonometric expressions, they're rarely going to be the same. You will have all kinds of different denominators you need to get rid of. But we will tackle that when we get there. Any questions with B? This point, negative 3 comma 8, is on the terminal arm. Is that on the unit circle? Well, no, the unit circle goes from negative 1 to 1 in both directions away from the origin. Negative 3 comma 8 is way outside the unit circle, so we can't say r is 1. We can, however, do this. We can write tangent right out of the gate. It's y over x. And you could put the negative on the top if you like. Or leave it on the bottom. I don't care, as long as you recognize it could be on the top. Cotangent is the reciprocal of that. But for everything else, what are we missing? We don't know r, right? Well, this is what I mean by simple math. You know x and y. Finding r is the Pythagorean theorem. It's not difficult. We're going to have negative 3 squared plus 8 squared equals r squared. I think that's 73. So r equals root 73. 73 is not simplifiable as a radical. 4 doesn't divide into it, 9 doesn't divide into it. So that's r cosine x over r. Secant, take the reciprocal. Sine y over r. Cosecant, take the reciprocal. One little bit of business, just a little detour. And I wish we didn't have to do this, but sometimes you do. Do you remember in Math 20 this kind of rule? We don't want denominators that are radicals. So if you wanted to, or you needed to, you could take this. Was this the cosine of the angle? Okay. And multiply the top and the bottom by root 73 to get negative 3 root 73 over 73, which, according to the powers that be, is simplified. I look at this and I ask myself, in what universe is that simpler than that? There is another reason why we don't want it on the bottom, but the basic reason why we teach you that in 20 is so when you get to calculus we can talk about rationalizing. But there's nothing necessarily truer about either of these. So I point this out because it could be that you see this on an exam. when you see a radical answer that's different than yours, run your answer through the calculator, run the one that you suspect is the same through the calculator to make sure they're equal. Angle B lies in quadrant 2, and cotangent of theta is negative 2/3. So cotangent is x over y. Can you rattle that around upstairs and just make sure you understand why I know cotangent is x over y? Tangent's y over x, which we should know from last year. We just reciprocate it. You see that this negative is put right smack dab in the middle? Okay. Which is negative? Is x negative or is y negative? Just because I like to write it on the top doesn't mean that x is negative, although it is. Why do I know when I start equating these things? Why do I know that x is negative 2 and y is positive 3? Why can't x be 3 and, why can't x be positive 2 and y be negative 3?
Because it lies in quadrant 2.
It tells you where it is. It's in quadrant 2. So you should know that in quadrant 2, x is negative. If it had said quadrant 4, even if I put the negative upstairs with the 2, it would belong in the bottom. What are we missing? To find the other 5 trig ratios, well, this one's easy. Right? Tangent and cotangent are reciprocals. But to find everything else, I need r. Again, simple stuff. Negative 2 squared plus 3 squared equals r squared. I think that's 13. So r equals root 13. And by the way, we don't write plus or minus. You can and then go, oh, except it can't be negative. R is always positive. So cos negative 2 over root 13. Whoops. Negative 2 over root 13. Secant, the reciprocal, which would still be negative, but the numbers are flipped. Sine is 3 over root 13. Cosecant is the reciprocal, root 13 over 3. And we are done. There's not a lot to this idea. I appreciate the frown when I do that, because then it tells me that I wrote something down incorrectly. Cosecant is root 13 over 3. Any questions with 5? Can you confirm there's one question left? This is the one that catches more people than anything else we've done today. So secant, oh, no, it isn't necessarily. There's another one that will catch you. Secant is 7 over 5. So what we're going to do here is say, since secant of theta is r over x, and just the fact that I paused as I'm thinking about that tells you I'm thinking about it. I have never memorized these. I said secant is the reciprocal of cos, and in my brain I said cos is x over r. Oh, secant is r over x. I go through that process all the time. Unless I immediately go to another question that has secant, I'm not going to know it's r over x without some thought. And this is equal to 7 over 5. So this is 7 and this is 5. I mean, don't get me wrong, you can still get caught on this question. There's a wrinkle to it. If I want to find cosecant, this would be a good multiple choice question, then my brain needs to say that's r over y. And I would ask you to think about that for a second. Cosecant, which is what we're after, is the reciprocal of sine. Sine is y on the top, r on the bottom, so I flip that over. But clearly what I'm missing is y, and this is not a long-winded question. I just need to know what y is so I can put it over into what I wrote in red. And I have this relationship, which is always true. X is 5. R is 7. By my count, when I take 7 squared minus 5 squared, I get 24. So y squared equals 24. Y squared equals 24. Y equals root 24. I want cosecant of theta, which would be root 24, which would be r, which was 7 over root 24. Are you all okay with that? Is anybody not okay with it? Why not, Thomas?
You can take the 24 into 2 with 6.
Okay, so I can take the 2 out. Root 24 can be simplified. I'll just show that here. It's root 4, root 6, which is 2 root 6. Cosecant of theta equals 7 over 2 root 6. Is everybody okay with it now?
Should be plus or minus.
Right. When we take the square root, it's plus or minus. Now, which is it? We've seen cases in math in this class and in Math 20 where the or means actually both. We end up with 2 sets of solutions. 2 x-intercepts maybe. But we've seen cases where you have to look at the context of the question and pick which one is right because maybe one is not right. And one is not right here. And you're told up here, don't just, I know we get used to seeing stuff like this and you go, it probably doesn't matter. It does matter here. You're told cotangent of theta is negative. And cotangent of theta is x over y. Now, what does that mean? It means that x is negative and y is positive, or x is positive and y is negative. One of those 2 coordinate parts has to be positive and one has to be negative. But since secant was positive, x was positive. And that means that y actually has to be negative. So we would write y equals plus root 24 or y equals negative root 24. But this one doesn't fly. You know, another way to look at it is, and this is maybe a little more thought, since secant is positive, x is positive. So if you look up here at my arms, theta has to be in one of these 2 quadrants. It has to be in one of these 2 where x is positive. But cotangent is negative, and the 2 quadrants that cotangent is negative in, by the way, are the same 2 quadrants that tangent is negative in, these 2. So there's only one quadrant where tangent or cotangent is negative, and secant or cosine is positive, and it's down in quadrant 4. So anyway, the bottom line here is we need a negative on this, and that's our answer. Really good numerical response question, cosecant of theta equals negative a over b root c, where you have to identify the 3 values of a, b, and c. A lot in this lesson. We're getting more practice with the unit circle and finding exact values of trigonometric ratios. But then we're all about the XYR thing and those other 3 trig ratios.